Hello students, hope you are doing well. In this video, we are going to look at the other topics of the chapter waves and sound waves. So the concepts that we are going to cover in this video are stationary waves on strings and loss of transverse vibration of strings. Now first let's look at stationary waves on strings, or how are stationary waves formed on strings. So now let me take a string which is stretched. What do? I plug the string at the center. Now how is this vibrating? This is vibrating like this, the pole. Now this is the wave of maximum wavelength that can be produced on this particular string. So this is the resultant stationary wave that we are seeing. But how is the stationary wave formed? The stationary wave is formed due to the superposition of two waves which are traveling in opposite direction. Now from where are these two waves coming? I'll take this example. I'm disturbing this. So the disturbance travels in this direction, disturbance travels in this direction. At the nodes, the disturbance gets reflected. These reflected parts are traveling in opposite direction and they are similar in nature. So the superposition of the reflected waves from the nodes is responsible for formation of stationary wave. So I hope that is clear. So why are stationary waves formed on strings? This is because of superposition of the reflected rays from the two nodes or the 2 points where the string is tied. Now here I'll say this part. This is this of course this one with n equal to 1. This is antinode, and we have two nodes, node and node. Now separation between node and node is how much? It is equal to lambda by 2. So here we have L equal to lambda by 2, or that would imply lambda equal to how much? 2L. Now frequency is given by V by lambda, so that can be written as 1 by 2L. V is root T by mu. So this is called first harmonic. The name given to this is first harmonic, or now we call it as either first harmonic or we call it as fundamental frequency. It can be either called as fundamental frequency or first harmonic. Anything is fine. Now let's look at the next waveform that can be formed. I pluck it at 1/4 of the, let's say, length. Then I'll have an antinode at the point where I pluck, and I'll always have a node at the ends. So I'll get a wave like this. So something like this, n equal to 2. So in that case, what will happen? I'll have this whole is lambda. So I'll have lambda equal to L. So that would imply F2, that is second harmonic, equal to 1 by L into root T by mu, which can be written as 2 into 1 by 2L root T by mu. So this is called second harmonic. So what did we get? We got second harmonic. Frequency of second harmonic is 2 into 1 by 2L root T by mu. The name given to this is second harmonic or first overtone. So these are the two notations that we use. Now n equal to 3, I have 3 loops. I can directly show it from here. Separation between two successive nodes is lambda by 2, lambda by 2, lambda by 2. So the total length, I can say 3 lambda by 2 is equal to L, or lambda equal to 2L by 3. So what will be frequency? F3 would be equal to V by lambda. So 1 by 2L by 3 into V is root T by mu. So I can write F3 equal to 3 by 2L into root T by mu. So in this way, I can say nth harmonic would be equal to how much? It is n by 2L root T by mu. So the frequencies that the string can produce are integral multiples of the fundamental frequency. I cannot have frequencies which are half integral multiples or fractional multiples of fundamental frequency. So now again, the name given to this one is called third harmonic or second overtone. Similarly, this one is called nth harmonic, so I can, or n minus 1th overtone. So in this way, we have stationary waves formed on strings. Now, the things that we have to remember while considering stationary waves formed on strings are, how are the stationary waves formed? They are formed by superposition of reflected waves. So, superposition of reflected waves is responsible for formation of stationary waves. Then at nodes, at the points where the string is tied, we'll always have nodes. So wherever string is tied, we'll always have nodes. So these are always nodes. And the next important point is the point where the string is plucked. Point where string is plucked always acts as antinode. Wherever the string is plucked, it always acts as antinode. So this is the conditions that we use to find the frequencies that a stretched string can produce. Now based on this, we give some loss of transverse vibrations on strings. We'll take the reference as f equal to fundamental frequency, that is f equal to 1 by 2L root T by mu. Here you can say that f is directly proportional to root T. So one law is frequency is directly proportional to square root of tension. This is law, first law. The next law is frequency is inversely proportional to linear mass density. So F is inversely proportional to square root of linear mass density. This is the second law. Now don't bother about the number of the law, this is the law. And F is inversely proportional to length. That is, F is inversely proportional to length. These are the three laws. That is how the frequency varies with length, how the frequency varies with linear mass density, and how the frequency varies with tension. So these three equations are called laws of transverse vibrations of strings. So what all things we have seen in this video? We have seen how stationary waves are formed on stretched string. They are formed by the reflected waves that are coming from the two nodes or the 2 points where the string is tied. Then the various harmonics that are formed on the string. So when I pluck it exactly at the center, I get the largest wavelength or the minimum frequency that can be produced. And depending on where I pluck, I'll have some frequency which will be an integral multiple of the fundamental frequency or first harmonic. And from the expressions of fundamental frequency, we derived loss of transverse vibration, that is frequency is directly proportional to square root of tension. Frequency is inversely proportional to square root of linear mass density, and frequency is inversely proportional to length of the string. Thank you very much for watching this video in specific, and thank you very much for watching Get My Classes, other videos and other questions and their solution. I'm sure that these videos are going to help you a lot in your preparation for competitive exams. Keep using them. Thanks a lot once again for using Get My Classes.